Okay, welcome to Chemistry Class Notes. This is your titration quantitative analysis for your practicals Waec Chemistry 2024. So, I stumbled on this question concerning titration between potassium, potassium manganese 7 and iron 2 sulfate. So I decided to use this as for your preparation for your quantitative analysis. So let's answer this question to prepare you. I'm not saying this is the exact question. This is a Waec, I think 2018 question. So I'm going to read the question, then we'll solve it. So E was prepared by dissolving 33.60 grams of a mixture of iron 2 sulfate and heptahydrate and sodium chloride to make 1 dm cube solution. F was 0.0200 mole per dm cube potassium manganese 7. 25 cm cube of E was prepared into a conical flask, acidified with 20.0 cm cube of dilute A2SO4 and titrated with F. Record the volume of your pipette, tabulate your burette readings, and record the average volume of F used. Equation of reaction. Of course, this is a redox reaction. Of course, you should know that this is a redox titration also, right? So this is your equation. Just know the potassium tetraoxide manganese 7 is the one you are putting inside the burette, while the iron 2 sulfate is the one you are putting inside the conical flask. So F is KMnO4, E is FeSO4. This is representing F. Sorry, this is representing F, and this is representing E. So let's look at the other part of the question. From a result and information provided, calculate concentration of FeSO4 7H2O in E in mole per dm cube, concentration of FeSO4 7H2O in E in gram per dm cube, percentage by mass of FeSO4 7H2O in the mixture. So these are the molar masses. So when I start to calculate, you can always go back to your question since you have the question now. Alright, this is my table. Take notes, I didn't perform this titration, right? So I just made up these values so I should to explain this particular question. Of course, you are expected to carry out your titration on that day. It doesn't mean you use my value. Your value is depending on what your teacher tells you. Alright, the first thing I will do, I have to record my volume of pipette. So I'm saying volume of pipette used 25.00 cm cube. Burette readings, final burette reading, initial burette readings, put the unit cm cube, volume of F used. Remember, I said the F is representing potassium tetraoxide manganese 7, which is the one that you put inside your burette, right? So rough first, second, and third. You can stop at second depending on what you want. So when you do everything, at the end of the day, when you subtract, I use these three values because they are not the difference between both of each of them are not greater than 0.2. Unlike this guy here, I don't want to use this rough because it's more than 0.2. So I have to use 1, 2, and 3. So after you've done all this one, which we are used to all this by now, the volume of F used is 22.50 cm cube, right? VF is 22.50 cube. VE is 25.00 cm cube. Always put the unit. So let's calculate. C E VE over CFVF equals to, the mole ratio is 5 to 1, right? We're given these two. We know this one from your question is 0.0200. This is 25. Sorry, this is 22.50. This is 25 cm cube. We are looking for this, so I'll just slot in the values, which is this is what I'm looking for, times VE is 25 is 0.0200 times, this is 22.50 equals to 5 over 1. You just cross multiply and make this one instead of the formula. At the end of the day, you get something like this: 5 times 0.0200 times 22.5 over 25. At the end of the day, when you multiply everything, you divide, you should get this is 2.25 over 25. The answer will now be 0.090 mole dm cube. Mole per dm cube. Put your units, very important. So that is the concentration of FeSO4 in mole per dm cube. The next part, we have to calculate the concentration of FeSO4 in E in gram per dm cube. We know that concentration in gram per dm cube is equals to concentration in mole per dm cube times molar mass. We know this, to calculate this one now, we know this. So we have to, this one is the one we just calculated. This one is 0.090, the one we just calculated. Then the molar mass of the FeSO4 7H2O. We have to calculate the molar mass of FeSO4 7H2O. FeSO4 7H2O. We are given the values. Fe is 56, that's 56 plus 32 plus O is 16, 16 times 4, that's 16 times 4 dot, that is you are adding everything, plus 7. Remember, this 7 is multiplying everything here, so it's like 7 into O is 16, H is 1, 2 times 1 2, 2 plus 16 18, that is 7 times 18. So when you do everything, this will now be 152 plus 126. Everything will now be 278 gram per mole. So this is the molar mass of FeSO4 7H2O. So to calculate the gram per dm cube, I'll just slot in the values. Concentration gram per dm cube, that is of E is equals to 0.0900 0.90 times this one we just calculated, 7278. So your answer will be 25.02 gram per dm cube. So this is the second part of the question. Remember, the values I made up the titration values so that I can, use it to explain the question. So the third part, they say find the percentage by mass of FeSO4 7H2O in the mixture. So percentage by mass, that's the mass concentration over the total mass of the mixture times 100. Remember, the mass concentration is the one we just calculated, which is 25.02. Then the total mass of the mixture is what they gave us in the first part of the sentence of this question, 33.60. You can look back at your question, 33.60 gram per dm cube. So the percentage by mass presented by mass of E is 25.02 over 33.6 times 100. Remember, these two, they have the same units, gram per dm cube, gram per dm cube. If you watch the first sentence of the question, they said E was prepared by dissolving 33.60 gram of a mixture of FeSO4 and sodium chloride to make 1 dm cube. If that value was not in dm cube, you have to convert it to dm cube so that you can use it to solve this question. Otherwise, the question will be wrong. So since that value was in dm cube, so we have to use it like that. So when you do this, you should get everything will be 74.46%. This is approximately 74.5%. So that's the percentage by mass of E. Remember, this is to guide you. This is not the question. This is not the exact question that's going to be out that day. This is just to guide you. Okay. The last part of the question. So yeah, they said, explain briefly why hydrochloric acid cannot be used to provide an acidic medium in titrations involving potassium tetraoxomanganese 7. 2. Explain why the upper rim of the meniscus is red in potassium tetraoxomanganese 7 titrations. And the last one, why was no indicator used in the titration? Okay. So for this first one, explain briefly why hydrochloric acid cannot be used to provide an acidic medium in titrations involving KMNO4. Remember, before you do your titration, after you've added your burette, your KMNO4 into your burette, and your FeSO4 into your conical flask, the next thing you have to do is to add H2SO4 into your conical flask. That is the first step before you start to titrate. KMNO4 is a strong oxidizing agent in an acidic medium, right? But in this question, they are saying, instead of KMNO4, why do you not use hydrochloric acid? I mean, since both of them are acid now, why didn't you use hydrochloric acid? Why can you not use hydrochloric acid? So the answer is that hydrochloric acid cannot be used because KMNO4 will react with it to produce chlorine gas. So when you see this kind of question, you say that the reason hydrochloric acid cannot be used is because KMNO4 will react with it to produce chlorine gas. So the next part of this question, explain why the upper ring of the meniscus is red in KMNO4 titrations. Of course, unlike your normal titration that you do when you put acid inside the burette, you notice that it is transparent. You can see all the markings, the ring, everything, you can see it. But in the case of KMNO4, it's purple in color. You can't actually see those markings, and that's why we take the upper meniscus. Unlike your normal titration, it's the lower meniscus you go for because you can see it's transparent. You can see the ring, but KMNO4 you can't see it. So the answer is that the lower meniscus cannot be seen. That's why the upper meniscus is red, right? I said the reason why the upper rim of the meniscus is red in KMNO4 titration is because the lower meniscus cannot be seen. That's a simple reason. So the last part, why was no indicator used in the titration? If you notice, we didn't add any indicator. But one other thing you should know, during the titration, when you've added your acid to your conical flask, which contain your iron 2 sulfate, then you start to add the KMNO4 from your burette and you start to shake until you get a consistent color. You notice that the color change is from colorless to faint or pale pink. That is the end point. The color at the end point is pale pink, just in case you're asked. The color change is from colorless to faint or pale pink. Why was no indicator used in the titration? No indicator was used because KMNO4 is a safe indicator. That is the simplest reason why indicator was not used, because KMNO4 is a self-indicator. That is all. So that's the end of the video. If you enjoy it as usual, leave a like and subscribe. Remember, this video is for quantitative analysis, your titration. Once again, the table I used, I did not perform the experiment. I just used those figures to explain this question for you. Until next time, bye.